now that we know the symbols of the metric system and what the base units are, let's look at how we actually use the apparatus or tools to get those measurements. First, let's look at measuring length. When we measure length, we use a metric ruler or a meter stick. The divisions are 1 centimeter divisions. In between those marked numbers is a millimeter, so there is 1 division smaller. So we have to estimate between the millimeter divisions. So if we look at this ruler, we can see that it is measured in centimeters. Each centimeter is divided by 10, so that would be the millimeters. We need to read between the lines or acknowledge how many increments there are. So we have 2 centimeters. The 4 is telling us we have a millimeter, and it's there on the line. That 0 tells us we feel it is exactly on the line. So you always have 1 more digit than there are increments on the ruler. Here's another ruler, and if we look at the arrow, we see that we are beyond the 2, so we have 2 centimeters. We are also beyond the 6 mark, so we are going to acknowledge a 6, and the arrow just goes a smidge after the line, and so I'm going to give it a 2. Maybe you want to give it a 1, maybe you want to give it a 3. It doesn't matter. We guess 1 digit beyond the increments, and that lets us know how many increments that device had. When measuring mass, we use an electronic balance for things that are not extremely heavy. We write all the numbers that are printed on the screen, and we need to make sure the unit says grams. If you're unsure how to check that, please ask me when you're in the lab so we can verify it's on the proper setting. When using the triple beam balance, we can measure accurately to the 0.1 grams, and that means we have to estimate to the 100th spot. So it's also a centi balance, meaning we need 2 decimal places. In the picture, we see the 100 beam is at 0, the tens beam is at 20, and the gram beam, we go beyond the 7, so currently we have 27. We go beyond the 0.5 mark, so I'm guessing it's 0.6, but it's not quite to the 0.7, so I'm going to give it 27.68 grams. You could say it's 27.69, or maybe you feel it's on the 7, so you give it 27.70. The point is, you must have 1 increment, 1 digit, beyond the increments that are on the apparatus. For measuring volume, the amount of space is occupied by the object is called the volume. So the amount of space that something takes up is volume. There is no specific way to actually measure an object's volume. There are a couple of different ways you can do this. The strategy for measuring volume depends on the shape of the material. So you have to assess what the object looks like to determine if you can measure it with geometric measurements or use displacement or another means of measuring. So for measuring a volume of a solid that is geometric, we can use the volume measurements by multiplying length, width, and height. So you would typically, the volume is measured in either cubic centimeters, so cm with the superscript of 3, or cubic meters, m with a superscript of 3. You would follow your instructions, or how we decided to measure using a meter stick or ruler when measuring these. So you still have to guess 1 increment beyond the actual increments of the ruler. So guess or estimate 1 place beyond to say if it's on the line or not on the line. So if you're using a centimeter ruler, you'll need 2 decimal places in doing that. When we measure a volume of a liquid or irregular solid, We will use graduated cylinders for small items. Usually the cylinders go up to a liter for accurate measurements. If we have larger volumes that we need to measure, we can use a beaker, but these measurements would be less accurate because beakers aren't calibrated for measurements. They're kind of more of an estimation. They're mass produced and cheaper, so you'll get a less accurate volume for doing that, but it's okay. With large amounts, the accuracy sometimes is not as important. The most common units for volume whenever you're using a grad cylinder is liter, and in our lab we're going to be using more often milliliters because we're going to be using small grad cylinders that measure 100 milliliters or less. If it's an irregular object, we will use displacement. So we'll measure a volume of water, put the object that you want to measure into the water, and then remeasure the water and subtract the two values, and that'll give you the volume of your actual object. So when you measure the volume of a liquid, you do use the graduated cylinders, as we said. And the first graduated cylinder is a 50 ml grad cylinder. Its increments are the 1 mark, so you can see it's the big ones say 10, 20, 30, and then there are lines in the middle giving you the 1 through 9. We can see that the water is at the 5 area, and if we feel it's on the line, we would put a 0.0. If you feel it's below the line, you could say it's 4.9, or above the line is 5.1. The 25 milliliter graduated cylinder is large increments of 5, 10, and 15, and you can see that at the 5 line, there are some increments there, and with this guy, it's probably not the best picture because it makes it look like there's 10 lines between there. So 5 divided by 10 would actually be 0.5, so that makes it a little confusing to measure. If they were increments of 0.1 or something else, we could add a decimal place. So that cylinder is not very typical of what we would have. We would either have 1 mil increments or we could have 0.1 mil increments. So you'd have to look at your cylinder. And then we have a 5 mil cylinder, and we shouldn't use that one for 5 mils of water because it's actually going to the line, and your measurement should be between the increments that are on there. So it should be between 1 and 5, but not at 5. It's too close to the top of the line to measure it because your meniscus would be hard to see if it were there or not. For measuring the volume of an irregular solid, as I said earlier, you'd use displacement. So you have the cylinder to the left. We have around 20 mils of water. Then we put our rock in there, and the water raises, and I'm going to say it's around 23.0. It's kind of hard to see on the picture. And so the rock volume is actually 3 mils. So you measure the volume without the object, add the object to it, measure the volume again, and subtract the two volumes. And once again, you are using the idea that it was incremented by ones, and we could say it's on the line or not on the line. So for measuring temperature, we're going to use the unit degrees C. Even though the SI unit is Kelvin, it is easier for us to use degrees C because our boiling point is 100 degrees Celsius and our freezing or melting point is 0 degrees Celsius. So it helps us measure water, and we can use that scale and we get nice increments of tens. The thermometer to the left is estimated to be 20.45 degrees Celsius. The increments on this thermometer are 0.1, and so we need to add the extra decimal places for the thermometer. And I kind of felt that it was between the 0.4 and 0.5, so I kind of just gave it the value of 0.45, and you could, say something different, and that's fine. The thermometer on the right, the increments are 2, so that makes it a little tougher. I felt it was at 12 degrees C. I really can't throw in an extra decimal exactly like some people would say it's 12.0 to say it's right on the line. But if it's in between the lines, we're actually at 13 and not 12 point something. So that does get a little fuzzy when the increments are 2s. And that also happens for graduated cylinders. So we kind of need to be careful with that. We can, try to avoid using them. It makes life a little bit easier. In all, when we look at measurements for every apparatus that we're using, we need to read between the lines. You definitely need to guess or increment one digit beyond the increment, so that's very important. That does show the accuracy of the instrumentation that's actually being used. And if you feel it is on the line, make sure you have the appropriate decimal places to indicate the increments of the apparatus. So the bottom line is just get that one extra digit in for every measurement. And that's what we'll be looking at whenever we do our measurements on the test. There may be items for you to measure. We're looking at, can you get that extra digit, that guess or estimated digit.